Hello everyone! Welcome to this tutorial where we'll solve Codeforces Problem 1367b, even array. This is a beginner-friendly problem where you'll practice logical reasoning and working with arrays. In this video, we'll 1. Understand the problem. 2. Learn the logic behind balancing mismatched numbers. 3. Use Python to implement an efficient solution. By the end of this video, you'll confidently solve similar problems. Let's dive in. Problem explanation. The task is, we are given an array of integers. At even indices, 0, 2, 4, the numbers should be even. At odd indices, 1, 3, 5, the numbers should be odd. If this condition is violated, we must determine the minimum number of swaps required to fix the array. If it's impossible to fix, we output -1. Input and output, 1. Input, the first line contains the number of test cases, t. For each test case, an integer n, the size of the array, an array of n integers, 2. Output. For each test case, output the minimum number of swaps required or 1 if it's impossible. Approach. Let's solve the problem step by step. Step 1. Mask the array. To simplify, we'll create a binary version of the array. Replace even numbers with 0 and odd numbers with 1. Step 2. Generate the ideal array. The ideal array depends on the size n. At even indices, we expect 0. At odd indices, we expect 1. Step 3. Count misplacements. Next, compare the masked array with the even array. Count how many numbers are misplaced at even indices, misplaced even. Count how many numbers are misplaced at odd indices, misplaced odd. Step 4. Feasibility check. To determine if we can fix the array, check 1. When n is even, the number of misplaced even numbers must equal the number of misplaced odd numbers. Count of even equals count of odd minus example. For n equals 4, indices are 0, 1, 2, 3, 2, 3. Both even and odd indices are equal in count. 2. When n is odd, there is one extra even index, so text count of even. 1 8 text count of odd. Example, for n equals 5, indices are 0, 1, 2, 3, 4, 2, 3, 4. There are 3 even indices and 2 odd indices. If these conditions aren't met, fixing the array is impossible, and we print -1. Step 5. Use XOR to find mismatches. To find the mismatches between masked array and even array, use the XOR operator. XOR returns 1 if 2 bits are different and 0 if they are the same. A 1 in the XOR result means a mismatch. The total mismatches divided by 2 gives the number of swaps needed. Example walkthrough. Let's walk through an example. 1. Step 1. Mask the array. 2. Step 2. Generate the ideal array. 3. Step 3. Count mismatches with XOR. 4. Step 4. Calculate swaps. Negative swaps equals 4 divided by 2 equals 2s. The output is 2, edge case. If the numbers of misplaced evens and odds don't match, fixing is impossible. For example, all numbers are even, so it's impossible to place odd numbers at odd indices. The output is 1. Conclusion. This solution is efficient and runs in IHON for each test case. It uses XOR to simplify mismatch detection and ensures feasibility with logical checks. If you enjoyed this explanation, please like, share, and subscribe for more problem-solving tutorials. Thank you for watching, and I'll see you in the next video.